Terrifying mistakes made during the Titanic submersible mission. At number 5, thrusters. The submersible is shown to have a total of 4 propellers, 2 facing forward and 2 facing up. These propellers are completely reliant on the battery packs. It is an unusual feature to have propellers for vertical movement in the water column. Very few other submarines do this. The reason is that the vertical propellers have replaced a depth control tank, which, while more complex, is also much more efficient and survivable. The thrusters are also relatively small and likely cannot provide the force to emergency surface a sub on their own, or at least not without taxing the power supply. They propel nearly 1-ton ships at 3 knots, or almost 6 kilometers an hour. If the frame of the sub were to get caught on any underwater debris, it is very possible the thrusters wouldn't have the strength to dislodge it. Coming in at the number 4 spot, battery packs. So given that the Titan was a battery operated watercraft, it may have suffered a power failure. Now ideally there would have been an emergency backup power source to maintain emergency and life support equipment, but it's unclear if the vessel had any power backup on hand. And unfortunately, the batteries, like all the other critical systems, seem to be primarily housed in the glass fiber tail. So while the lithium-ion batteries are rechargeable, efficient, and able to store large amounts of power, they are also highly flammable and explosive, especially when exposed to water. So back to the potential vulnerability issues with the hull, if the batteries were stored in the hull and the hull became compromised, it would likely have contributed to the disaster. At number 3, communications. Deep sea communications are challenging to say the least. Sonar is the only viable method of wireless control, but even it isn't consistent. Sonar is restricted into specific thermosilins or temperature levels within the ocean. Thermosilins are a surprising effect to experience, as temperature within the water column can vary several degrees over just a few feet at buoyancy layers. These thermosilins also act as walls to certain frequencies of sonar, with deeper pitches being able to reach further into the depths. However, the sub didn't seem to have deep pitch sonar of its own and would likely struggle to communicate with the surface. Indeed, communications only occurred in bursts of every 15 minutes, meaning the sub had a 15-minute window to disappear in between every check. 15 minutes is a viciously long time underwater. The USS Thresher went from being a perfectly functioning sub running a test dive to a massive ripped apart iron in the span of 9 minutes. Coming in our number 2 spot, unsuitable materials. Another theory about what could have caused the implosion is that the equipment and materials used were overall unsuitable for the depths they were going to reach. Former Marine Robert Mester, who actually declined going on a previous trip with OceanGate, said, quote, "They were using off-the-shelf hardware to operate inside, and quite frankly, we're talking about an environment that requires robust equipment that has certifications and qualifications that are established by different agencies for man-rated submersibles. None of the equipment that I saw inside the submersible was up to that level, so I just chose not to go." He then goes on to explain that the carbon fiber hull was particularly concerning, as it is apparently not a material that has ever been successfully used at great depths. And at number 1, rescue parties. The sub and the ship it was going to see are incredibly deep. So deep, most submarines will never reach those depths in their entire lives. This means that only a few other submarines and rescue vehicles are even capable of attempting such a recovery, and every single one of these vessels that could have saved the crew was nowhere nearby during the disaster. The vessel itself has 96 hours of life support. However, in the world of submarine rescue, 96 hours is nowhere nearly enough. At those depths, rescue parties are mostly limited to ROVs, which slowly scan the ocean floor a few feet at a time with their flashlights. Even these submarines struggle with the depth and pressure. In the best case scenario that the sub was waiting on the surface, they still wouldn't be able to escape, as the sub has no method of exiting from the inside. Sadly, no rescue parties will be needed anymore, as a debris field off the coast of Canada has been identified as the remains of the wreckage. It is some small comfort to know that their fear in the end were likely brief. As the moment a failure would have begun in the main hull, the whole section would have rapidly imploded, eviscerating everything inside faster than a human nerve could fire.